Hello class, so in this video we're going to be talking about infinite limits. So what that means is we're just going to see what happens when x approaches infinity or negative infinity. Most of the time, it kind of just works the same way, negative infinity and infinity. You're going to have a horizontal asymptote. However, there are some cases where you're going to see that it is different, and we can talk about those specifically later on. So let's just start by calculating this thing. Use logic to get through it. Alright, so we see that we have the limit as x approaches infinity of something. So let's do that. Let's do that to each term. So to that 3. And then taking that limit as x approaches infinity of 2 over x. X cubed, I mean. And then same thing, just continuing on to all of those terms. Now we can do the same thing to the denominator as well. Alright, to 2, and then same thing to 5 over x to the 4th. Okay, and then from the previous video, so there's a video I did before this. It's called function growth rates. That'll help with figuring out what's gonna happen with all of these things. So we see that, well, for 3 there's just a 3. There's no x, so we just get 3. But with the 2 over x cubed, we see that the growth rate of the 2 and the x cubed is different. The x cubed is a lot bigger than 2, and well, it's the only thing that actually matters. So the whole thing goes to 0. How about for the next term? So we have 1 over x to the 4th. So we notice that x to the 4th, obviously greater than 1, same thing will happen, goes to 0. Alright, how about the denominator? So we see that for the 2, same thing. No x, it's just 2. 5 over the x to the 4th also goes to 0. 3 over 2, that's just what we'll get in the end because we have all those zeros. So, this shouldn't have been too difficult. If necessary, again, review that video that I mentioned. That'll help with logicking through some of this stuff. So 3 over 2, that's what we get. And yeah, let's move on and try some other stuff. So since we saw that was doable, let's just try this. Are these equal? I suggest trying to do this on your own first. Just pause the video, I'll give you a few seconds. Okay, so we get this thing, and let's just try to make it so that the left-hand side equals the right-hand side. That's something we do a lot in math. Alright, so let's multiply by 1 over x to the 4th. You'll see why I decided to do that later on, but just kind of go with it for now. We'll see the algebra that goes on with it, and then, yeah. Alright, so if we distribute that term to each of the terms there, then we get 3 for the first part. And then so we get 2x over x cubed. Actually, I'll write it up here to just make it a bit easier. So it's kind of out of the way. So an x and an x are going to divide out of the numerator and denominator there, and the power in the denominator is just going to reduce by 1. And then negative 1 times it's just negative 1 of itself. Now we have 2 plus that'll just be 5 times itself, so we get this. So yeah, we saw that we get the same thing left and right, so let's see what happens with the limit. I mean, if it's the same thing, then that means the limit as x approaches infinity of 3x to the 4th plus 2x minus 1 all over 2x to the 4th. Sorry. Photoshop is glitching a little bit. Plus 5. That is going to equal 3 over 2, since it's the same thing as the previous quantity. Alright, so that also means that we can say that for this function, the horizontal asymptote is going to be y equals 3 over 2. So that's kind of a significant thing you can take from this type of analysis. And what I just did was actually a method where we multiply the numerator and denominator by 1 over the highest overall dominant term. So this is overall, not just the one in the numerator or just the one in the denominator. It doesn't matter which one we choose as long as it's the overall one. And you can check out what dominant term means in the previous video I keep referencing. Alright, so let's try on these things. Let's see what's happening with the dominant terms. So this first limit, so these are going to be the same problems actually from the previous video. Let's see what we can multiply to this. So I chose 1 over x squared. The reason is because it's the same dominant term in the numerator and denominator, so it doesn't actually matter. Just choose that same thing. Distributing and just doing algebra, we get this over 2 minus 4 to the 4 over x squared, sorry. And then what ends up happening is the 1 and the 2, they're just there, and the rest of them, those are gone. So we just get 1, and then again, dominant terms in each of those denominators is greater than the numerators, so we get 0 there. Denominator, that 2 minus thing, we get 2, and then what happens there? That also, like the numerator, goes to 0. So we just get 1 over 2. So this should make logical sense at least. Because if we look at the degree of the numerator and denominator, we see something happening. So when you're taught about horizontal asymptotes, it's normal to be taught that you compare the degree of the numerator and denominator. In this case, they're the same. And normally when they are the same, what you do is just compare the leading coefficients. Because since the numerator and denominator have the same growth rate, that means the function itself is going to be growing approximately at the same rate. The only difference is that 1 over 2. Is the 1 and the 2. So same growth rate, and they're just different by multiplication. So the ratio between those is just 1 to 2. So that's why you get the horizontal asymptote as y equals 1 over 2. Alright, so let's look at another one. So here we have factorials in the numerator and denominator. Same degree factorials, so let's work with that. 1 over x factorial divided by 1 over x factorial. And then we'd get the limit as x approaches infinity of, that'll be 4 minus 1 over x factorial divided by, and that'll be, so that'll give me a 3, and plus 1 over x factorial. Alright, so similar analysis as the previous things. We get a 4 and a 3. Those are actually just going to stay the same, just like they have been. And the rest, they just go to 0. So here we just get 4 over 3. Alright, next one, we see we have an e to the x and an x squared. And e to the x is obviously a lot bigger than x squared. So we'll multiply this by 1 over e to the x, all divided by 1 over e to the x. Alright, so that'll give us a limit as x approaches infinity of, so that's just going to give us 1 in the numerator. And in the denominator, we just get each of those terms divided by e to the x. You can't exactly simplify it like you could with the other polynomials, where you're able to just cancel out x's and stuff. In this case, you can't do that because that's an exponent. But something nice does happen if you use function growth analysis on this. You'll notice that each of the denominators there is e to the x, and the numerator is small, so essentially that just all goes to 0. So we get 1 over 0, which is obviously not a number, but essentially what that means is this thing is going to be infinite. So limit approaches infinity. Alright, so here we have the reciprocal of that, just like we did in the previous video with this. So we already know 1 over e to the x. So yeah, let's actually just go with 0 over 1 because we know that's going to be the result. And what do we get? That is just 0. So there's 0, there's infinity. In this case, we got 0. Okay, so let's look at what happens with the next one then, 1 over x squared. So you see me about to do the multiplication thing. Let's not, because that's actually going to be pretty pointless. That'll literally give you the exact same thing. Yeah, so we just know that this is going to be 0. We've already seen this over and over in this video, so let's not worry about it too much. So now let's actually look at one thing. So here I'm taking the limit as x approaches infinity of e to the x. That is going to approach infinity. But what about the limit as x approaches negative infinity? In this case, it'll actually be different. We get 0. Part of it is knowing what the graph looks like. So e to the x, it looks approximately like this. And this is one of those basic parent functions that you should more or less be familiar with. So you got that, you got this horizontal asymptote here. And yeah, so as you can see, as x goes toward the left more and more, function just approaches 0. It approaches the x-axis. So graphing does help with seeing these things, because you can literally see the trend. So let's look at another one, which is going to be tangent inverse. Just a very, very, very quick sketch. Let me make that better. Yeah. So what we end up seeing then is that this thing is going to be approaching some specific numbers, but they're going to be different toward the right and toward the left. Pi over 2 for the right and negative pi over 2 for the left. Alright, so this is infinite limits, and they're not too difficult, just logic through those things with the growth rates. So that'll be the end of this. Thank you for watching, and I will see you in the next video.